So control of microbial growth, and this really is very much related to what we've been talking about, which is growth, right? So the important things that we have to maintain for growth, if we mess with any of that, right, we could prevent or control growth of microorganisms. So you can do this physically or chemically, right? So your homework assignment was the discussion board, right, to look at the chemicals that you use to clean and how they work. And so we'll talk a little bit about that. You can combine these methods as well, right? So physical methods that we most commonly use are heat. But you could also look at the flip side of that and just refer to it as temperature, because we also use cold, right, as well as to control microbial growth. Irradiation, and we'll talk about the different forms of that, different types of filtration, and then mechanical removal. What do we mean when we say mechanical removal? Scrubbing it clean, right? When you wash your hands, right? That's mechanical removal if you're just using water, right? And if there's no soap in the bathroom, just water and rubbing your hands, right, is mechanical removal of organisms. Chemical, right, we use a variety of antimicrobial chemicals, and it really depends on the circumstances and the degree of control required as to what we use and what it does, right? And hopefully you learned a lot about that as you were doing the discussion board. So as it relates to controlling growth, there's different levels of control, right? So we need to know the definitions, be able to define and understand each of these terms, right? And be able to make the important distinction between antiseptics versus disinfectants. So for sterilization, the definition needs to be more than just the removal of microorganisms, right? The term microbes is usually the term that's used more widely, and microbe refers to microorganisms as well as things like viruses, which are not living, so you couldn't call them an organism, right? They're not organized to the organism level. They're not even a cell. And then you also have to take into account the dormant cell state that some bacteria can form, which are endospores. So all these things that could potentially be damaging to us. We can achieve this level of clean, this probably the cleanest level, right? Because everything that could make us sick is not there. Some methods of filtration can achieve sterilization. Some heating methods can achieve sterilization. Some chemicals and even some forms of radiation, right, can render something sterile. Disinfection implies that most pathogens, most things that would make you sick, have been eliminated. This means that some viable microorganisms may exist, right? But hopefully most of the ones that would actually make you very ill have been eliminated. So there's lots of different terminology for the types of disinfectants that we use. A disinfectant is something we use on inanimate objects or surfaces, right? We clean our countertops. Inanimate is non-living, right? As opposed to antiseptics, which we would use on only living tissue, right? So biocides is referring to killing living things. Bio meaning living, side referring to killing. Germicide is more than just killing bacteria or fungi. Germs is another term that sometimes you'll hear that also includes viruses. Where a bacterial side is referring specifically to eliminating just bacteria, right? Its main target is bacteria. So, Windex, which is it? Disinfectant or antiseptic? Disinfectant, right? Windex can be a disinfectant and contains ammonia, right? Which is a base, right? So you're messing with pH when you use that, okay? Would you put that on your skin? No, right? Unlike my big fat Greek wedding, right, where he's soaking his elbow in Windex. not a good idea. Because if you read those types of bottles, it usually tells you not to expose it to your body, right? Most of the cleaners that you use, most of the disinfectants you use, if they're actually affecting microbes, right, say not to come in contact with your skin, right, to wear gloves, even sometimes to wear eye protection, that you don't want to breathe it in. So you certainly do not want to purposely get it on your skin, right, or within your body. Well, it's an irritant, right? So if you get it on your skin, it can be quite damaging, right, to your cells, not only just the bacteria that are present. So, but there are some antiseptics that can be used as disinfectants, or some that are disinfectants that can be used as antiseptics. There are some that do fall into both categories, right, that you could use to clean your countertops but are also safe to use on your skin. So things like 70% isopropyl alcohol, right? You can use that to disinfect your skin, but you can also use it to clean your countertops, right? But just because something is safe enough to use on your skin doesn't necessarily mean you would want to use it to clean your home. Like, for instance, iodine tincture, right? You can use this on your skin. It discolors your skin. A lot of times they'll clean up with alcohol afterwards, will help remove some of that discolorization. You would have to do the same thing. You wouldn't necessarily want to clean your countertops with iodine, right? Because it would leave a discolorization to them if you don't clean it up afterwards with something like alcohol. The important distinction here is that it's approved safe to be used on your skin, right? Hydrogen peroxide, although considered safe, nowadays are saying it's not your best choice, right? But a great cleaner for around your home, right? For your laundry, for your countertops, right? Because of how it interacts with cells. Pasteurization is brief heat treatment used to reduce organisms that would cause food spoilage and kill pathogens, right? Things that would make us sick. You can also pasteurize surfaces when people are using those fancy steam machines nowadays, right? You're quote unquote pasteurizing, right? Because you're using a brief treatment of heat, right, in the form of steam on those surfaces. Decontamination means that you've treated something to reduce the pathogens to a level that's considered safe. This is a very broad term, right? What is safe?
Right.
Right. Well, it means that, you've reduced them. So one of the things that factors into whether you get sick or not is how many organisms you're exposed to, right? So give you an example of what we call infectious dose, right? That's the minimum number of that organism you have to acquire to get sick. And the scary thing for things like tuberculosis, as little as 10 of those bacteria, if you were to inhale them, you could get that disease. Where things like salmonella, you'd have to ingest like 1,000 bacteria in order to get the infection. All right, so the number matters, right? If you're fighting just one person as opposed to a whole crowd comes at you, I don't know about you, but I'm running in the other direction, right? Me against one person, I might have a good chance, right? A whole crowd, forget it. There's no way. I'm not a, black belt ninja. That would be pure crazy. And that's the same thing for our bodies, right? If you're exposed to thousands of bacteria, then chances are greater that you're probably going to get sick, right? There's no way your body can defend against that large of a number, right? And then if it's a highly pathogenic organism that we don't have much defense against, like tuberculosis, as little as 10 of those guys can be a real serious problem for you, right? So that's where, to a level that's safe, it's going to really be situational, right? What was there, right? How much do you have to clean to remove it to consider it safe? And that's some of the constraints that we'll look at in a moment. Degerming is usually when we refer to decreasing the number of microbes on somebody's skin, right? We're trying to degerm you. And again, we're really focusing on things that would potentially make you sick. Sanitization implies a substantially, notice it says implies, a substantially reduced microbial population that meets acceptable health standards. This is not a specific level of control. This is not standardized. So how many people have dishwasher machine? Do you have a sanitize button? Yeah. How many of you guys push it? How many of you guys have babies? Infants at home? Not an infant, right? An infant? Okay. All right. How many have elderly? Okay. The elderly and the infants are the only ones that should be pushing the sanitize button. The rest of you don't need that level of clean, right? Because hopefully, right, there should not be large numbers of microorganisms where you have to increase the heat, right? That thing is already hot to begin with, right? Sanitize, all it does is increase the level of heat. So all you're doing to your electric bill is increasing that when you hit that sanitize button. If you've got an elderly or an infant, then you might need that extra level of clean, right? Even some dishwashers, some washing machines have that button nowadays too. Again, unless someone threw up on your clothes, right? Or you work at a doctor's office and somebody threw up on you, right? Or spit all over you, or pooped on you, right? If you work at a veterinarian's office, right? Then yeah, you might want to run your scrubs through the sanitize, right? Otherwise, don't need to push that button, right? But it's there for those types of situations, right? Which most of us are not in that type of situation, right? Most of you don't need that button, right? I never push that button, okay? My clothes aren't needed to be that clean, right? Make sense? Okay. Preservation, right? This is so that stuff will last longer, right? Preserve it. We want to delay spoilage. So things that can spoil, right, what we call perishables, we're going to add stuff to it that are going to impede or inhibit the growth of microorganisms that may be present. And I got news for you, most of your stuff comes what I call pre-contaminated. You're not getting stuff that's sterile, right? There's some microorganisms there, and over time they're going to eat that food that you want to eat. Right? And when they eat it, they typically turn it into something you don't want to eat anymore. Not always the case, right? We purposely ferment stuff. We purposely let microorganisms eat certain products to produce other products that we do like, right? But sometimes not the case. And especially if it's an organism that may be pathogenic to us, right? We don't want them growing, and we don't want to be ingesting them. So we want to prevent that growth.
Pasteurization and preservation is that this has something added to it, and yeah.
Mm-hmm. And we'll come back to it again. So the primary reason why milk is pasteurized. Why do we pasteurize our milk? Right, you're going to kill most microorganisms and most pathogenic organisms, right? It does help with spoilage, but that's not one of the main reasons why we pasteurize our milk, right? The main reason why pasteurization in milk started was to prevent disease, okay? Wine, on the other hand, the main reason why pasteurization was started, and it's actually named after Louis Pasteur, right, who developed the method, was to preserve it. So again, so that you reduce the number of microorganisms that would be eating or continue to eat, because actually wine is made through a fermentation process, right? But it's other microorganisms that may also get in, right, that would spoil the wine and turn it into something that we don't like. But there's even different types of pasteurization out there, right? And so we'll talk about that in a little bit more detail when we get to that level of cleaning. So how do we choose, right? how do we select which antimicrobial procedure we do, right? There's several factors that come into play, right? As we said, right? The extent of the contamination. What's the number of microorganisms present, right? That's really going to determine, and then even the type of microorganism, right? How bad is that may or may not be there or is there? So in the microbiology lab, right, if we spill a whole test tube of bacteria, we don't just spray Lysol on it and wipe it up. We spray and leave the Lysol there, right, for a good amount of time to help destroy the microorganisms before we wipe them up, right? So how many of you guys, after reading, right, for homework, some of the things you were cleaning with, were just spraying and wiping it up? How many of you guys found when you read the label, it says if you actually want to kill the organisms, what do you have to do? Wait. Leave it for 10 to, the average I think is about 10 minutes for most cleaners, right?
But I didn't think it worked. It was like, you know how you spray something and you leave it and it dries up? I thought by it drying up, it just...
Right, so good question. So if you spray it, and for some of them, you know, depending on environmental conditions, it may dry up. And in fact, in the microbiology lab, when we spray down with Lysol, we actually just wipe so that we spread it all out, so we cover the whole surface, and we leave it wet, and we let it air dry for a minute, right? Because in that warm room, it only takes about a minute. But that's actually sufficient for what we're doing in the lab, right? Lysol is a really good cleaner. It's really effective, right? So the other thing is if you're really worried, depending on the level of, right, how dirty it is, a lot of times when I clean my bathroom, I spray down the whole sink, right? I leave, go do something else. I come back, I spray it down again just to try and pick everything up as I'm wiping it down, right? That mechanical removal. But yeah, leaving it there and it drying is fine. Right? It's totally fine. And in fact, you want to make sure that the whole area is saturated, right, that you're trying to clean. Because if you just wipe it all up right after you spray it, it's not getting its time to work. Remember, these are microscopic organisms. You can't see them. Environmental conditions are really going to come into play as well, right? What type of environment are you dealing with? Can you actually use a spray cleaner, right? If I walked over to my husband's Xbox and started spraying it down with Lysol, he'd attack me, right? That's an electronic. If any of that got in any of the air holes or anything like that, forget about it, right? You could fry that thing. We know electronics nowadays, right? You can buy special cases for your phones, right, so they don't get wet. Because if it gets wet, there's a little indicator inside, and they won't, even if you have insurance, replace that phone. Right? Because you got it wet, right? And you're not supposed to do that, right? Electronics and water do not mix, right? So liquid cleaners, you do not want to, you know, electronics to get exposed to those. There are certain cleaners like that will affect what you're cleaning that may be corrosive, right? A lot of the cleaners that you use when you read the bottle, especially for Resolve, what does it tell? Anyone do Resolve or any carpet cleaner or fabric cleaner like that? What does it tell you to do when you first use it? You spray it all over the entire couch or the carpet. What do they say? Test it in a little area first. Because depending on what that carpet or that fabric is made out of, they don't know all the different fabrics and stuff out there. It might actually cause damage to it, right? So if you just spray it over the whole thing, right, instead of cleaning it, you just destroyed the whole thing, right? And they don't want to be held liable, so they're like, you better test it first, because we don't know, right? Against most things, we've tested it, but who knows what you're trying to clean. So the environment, right, what you're trying to clean, what is it, right, is really going to determine a lot of times how you attempt to clean it. The composition of the infected item. That goes into play with, again, you know, water and electronics don't mix corrosives and things like that. For environmental conditions too, acids and bases. Like some people think it's, oh, well, I'm going to mix these two cleaners together and that's going to be better than just using one. There's one mix between two chemicals you never do, and that's because it's a little bit different chemical reaction, but it's a chemical reaction, right, and can be bad, and that is what two cleaners? Bleach and ammonia, right? Chemical reaction will happen.
I put it in the toilet.
Yeah, not a good idea, right? They can form a gas together, and in fact, by law, right, because that gas can be toxic, especially if it's not a well-ventilated area, it could kill you, okay? No. See?
Yeah,
we'll save your life.
Have my bathroom smelling like a public restroom. So,
yeah. Just one. And then, like, the next day, use the other one if you want, right? You can alternate. Just don't use them together. All cleaners that contain either bleach or ammonia must have it listed on the label and must say not to combine with the other. And that is why. Okay. The other problem why you don't want to mix certain cleaners, because acids and bases, where's my chemistry people, what happens when you combine them? They cancel each other out, right? And the whole reason why we use an acid or a base is to push them out of their comfort zone, right? Well, if you use two cleaners that cancel each other out, you're not doing anything at all, right? So don't combine, right? You don't need to. You can alternate. That's a good idea, right? Alternating, switch it up on them, right? They don't know what's coming at them next, right? But do not combine. Surprised you hadn't knocked yourself out. Okay. So the type of microorganism, right, is really important, right? Is the organism resistant or susceptible to our generally accepted methods, right? Do we have a situation where there are endospores? Endospores are heat resistant. You can't dry them out to kill them. And numerous chemicals don't work on them, right? So if you have a situation where there's pathogenic endospores present, right, you have to take that into consideration in how you're cleaning. The good news for us, right, this isn't something you have to worry about in your home. Protozoan cysts or oocysts, right, these are typically excreted in one's feces and can cause lots of diarrheal diseases, right? These are the things we worry about contaminating our water supply, right? And so we have to take certain measures to make sure that they're not present, right? That we are not ingesting these things. Mycobacterial species. These guys are much harder to kill because of that special cell wall they have with the mycolic acid, right? And that's why we can stain them with the acid-fast stain and identify them. So Mycobacteria tuberculosis. That's why, as I said, as little as 10 bacteria can be damaging to you. And the bad news is, too, is that most of our cleaners aren't going to take care of these guys. The good news is hopefully you're not exposed. Pseudomonas. This organism is found in the environment in the soil. This organism can grow even in some of our disinfectants. Okay? It's not even killing it, it's growing in it. This is the main reason, this organism is the main reason why potted plants, right, aren't certainly being brought into burn patients' rooms, right, because of that soil component, right? They're already extremely susceptible to infection, having this damage to their skin, to their most protective layer. This is also why certain things that you use for your eyes are packaged one-time use only. They're not doing this to make you buy a whole bunch of things. They're doing this to help protect you. Because once you open it, it could become contaminated. And then you could introduce this stuff directly into your eyes. Right? One-time use only medications and things like that are done like that for a reason, to help protect you from contamination.
As an example of that.
So if you don't use the whole thing, still throw it out.
Wait, is that the same thing for like milk for infants? Because I remember when I was visiting my friend in the hospital, like as soon as he was born and they give the infant meal or whatever that is, whatever he drinks at that moment, that's what he drinks. But as soon as they put it down, they'll tell him throw it away and get a new bottle. Like, is that the same thing for that?
Yeah.
Okay.
Yep.
Yeah, they take it within 2 hours. That's what they.
Yeah, because, it's not a sterile environment. So microorganisms could become present. And especially being so young, they're more susceptible to that. So you don't want to expose them to anything that could have become contaminated. And very easily can become contaminated.
Have their kids walking around with a bottle for hours, like the whole day, just sucking on the bottle. And it just get under my skin. You can't.
Yeah. But I mean, it's depending on the age of the child. I mean, an infant's not doing that, right? As we age, our immune system, right, gets online and it is better suited. So that's not necessarily a bad thing for an older child that's up walking around, right? We're talking about infants, right, whose immune system isn't quite online yet. Right. So although probably not the best practice, not necessarily the worst either. But, people that, like, go to places like Walmart, with, a baby that's a month old, I'm like, seriously, you couldn't get someone else to watch that kid? That you do not want to be exposing them to that large number of people. And, I see a baby, I'll stand back and be like, cute. But, I don't go all up in his face, because that they're at a vulnerable stage, right? And they shouldn't expose. I mean, there was a reason why Mom stayed home, right?
So doctors will tell you that, well, I've been told that a baby is better, more, safer than the mother. The mother is more susceptible.
Yeah.
Because I have
because you're weakened.
In her 70s.
Yeah.
So she's old school, and you can't go out the house in a month or something.
Yeah, a month. Yeah. A month is a standard time for an infant. A couple days old, I mean, what the heck are you doing out of the house? Viruses. So viruses, right, aren't necessarily living, right, but they're definitely infectious. And there are 2 main types of viruses. There are envelope viruses, and these contain a membranous-like layer. It's not actually a membrane, it's called an envelope. But it's actually made from the membrane of the cells that they infect. So it's made out of lipids. And so just like with cells, like when we talk about destroying bacteria, certain chemicals affect membranes, right? So this envelope is very similar to a membrane in that it has a lot of lipid component to it. So it is susceptible to things that disrupt lipids, that disrupt membranes. So the good news is most animal viruses, most viruses that infect humans, are enveloped viruses. They have this layer. And they need this layer to be able to attach to us and then infect into our cells. So if we can disrupt that layer, right, with chemicals, with heating, then we can stop it from being infectious. So this is how we, quote unquote, can kill viruses with chemicals, right, is that we're disrupting that envelope layer. The bad news is naked viruses are called that because they do not have this envelope layer. They're protein coated instead, right? They're nucleic acid and protein. That protein is much more difficult to disrupt. So those viruses, right, are much more difficult to disrupt, to eliminate. But as I said, the good news for us is most of the ones that are infectious for us and create serious problems do have an envelope. So we are able to disrupt them, right, and stop ourselves from getting sick. So again, what's the risk, right? How clean does something have to be, right? If it's a critical item like a needle or a scalpel that's going to penetrate through your skin, that needs to be what? Sterile, right? No microorganisms, no viruses, no endospores. Because you're going to introduce them past your most protective layer. Right? This is why needles, again, are single use. Unless you sterilize it, you're not going to use it again. Most of us know that's why intravenous drug users who use needles over and over again, right, tend to get infections, right, because it's not clean, because of where it went. Semi-critical items, right, that may come in contact with your mucous membranes, so like an endoscope, right, where they're actually going down your throat. Non-critical items that contact, hopefully, unbroken skin, right? So therefore, very low risk, right? When the doctor puts the stethoscope on you, it's okay, right? It doesn't have to be super clean.
If you put, my doctor, my grandmother's doctor that's there now, anytime that he's using his stethoscope to,
he always wipes it with some alcohol.
no, he puts it in another glove, like he'll pick up the glove.
Oh, yeah.
And just put it in another
Yeah, to create a layer. Yeah.
Yeah, and I was wondering what was done there for me.
And mostly, that's just, an added level of precaution and safety. Makes some people feel better, right? But it's not necessarily necessary. Like, I won't kick my doctor out of the room if he's not, if he doesn't clean that or protect that, right? Because it's not, if I don't have any broken skin, anything that he puts on is not necessarily going to get through, right? And again, a doctor is going to, think about where he's put that, right, and how clean or not clean it is. His hands, on the other hand, is a whole nother story. They've definitely touched somebody and maybe, in areas that they shouldn't. Especially my gynecologist, right, washes his hands right when he walks in the room, right? If he didn't do that, I'd be walking out the door. Because you don't know what he touched. And a nurse that walks in a room with a pair of gloves on all the way, I'm like, bye. Right? You better put those gloves on in front of me that I know they're clean. Otherwise, I don't know what you touched. Yeah, you're protecting yourself, but what about me? Right? Do not touch me. Okay? When I had to have a catheter after I had my son, because the stupid epidural hadn't run off, so I couldn't pee, I watched that woman, open that package with all those sterile items. I watched her like a hawk. That's the number one reason for infections in hospitals, right, is being catheterized. And that's because, it's creating a free ride for any microbes, so if it's already contaminated when they put it in you, you're screwed.
I had the same problem after I had surgery, and they had some type of little thing that it cracked on my nose, I could smell it.
Mm-hmm.
And then it helped me use the bathroom. It was like a strong, real type of smell.
Oh, must be new. For me, that was 8 years ago, so it was a while ago. I tried desperately, but it didn't happen. Okay, so what do things like boiling and pasteurization, right, sterilization using steam, and this commercial canning process that we use, how do these things work? So there's different types of heat, okay? And it is the most commonly used form of microbial control, right? It's relatively fast, it's reliable, it's safe, it's inexpensive. It can be used to sterilize or disinfect. It just depends on what you're doing and how you're doing it, what level of heat you're using. So most methods, right, you're either using what's called moist heat, where there's some component of moisture, or dry heat. Moist heat is the most effective, and it is effective by completely destroying proteins, denaturing them, irreversibly coagulating them so they no longer function. And the main thing that catalyzes reactions in your cells, that runs your cells, are proteins. So if they cannot function anymore because they've been changed, right, they've been morphed, they've been melted, they've been denatured, they no longer can do their job. So boiling is a form of moist heat, right? Any liquid that you boil, right? Or anything that you put in boiling liquid. Pasteurization and pressurized steam by autoclaving are all examples of moist heat. So boiling, in order for it to boil, it reaches 100 degrees Celsius or 212 degrees Fahrenheit. This will destroy most microorganisms and even some viruses. But it's not an effective means of sterilization because there's one critical component that's not destroyed by boiling, and that's endospores. That heat-resistant dormant form that some bacteria can form. So, when we boil our water, right, to make it safe to drink, is it safe? Yes, because most of the time, it's not going to have pathogenic endospores in it. So you don't have to worry about the fact that you're not going to destroy those. Pasteurization, as I said, developed by Louis Pasteur, mainly to avoid spoilage of wine. It does not sterilize, but significantly reduces organisms. It's used to increase the shelf life of food, as well as to help us, right, especially when it comes to milk, to prevent contamination that would make us sick by pathogens. There's two main forms of pasteurization, and more nowadays people are being exposed to the second form of pasteurization. The first is high temperature short time. So whatever it is heated, whether using steam, right, or if it's a liquid, it's heated to 72 degrees Celsius and held for 15 seconds. This is typically how things are pasteurized, and lots of things other than milk are pasteurized, juices, and again, to increase shelf life. Another protocol is ultra high heat. So it's heated to 140 to 150 degrees Celsius and held for a few seconds and then rapidly cooled. So this is becoming more and more common here in the United States, although it's been used widely in Europe, because when you ultra pasteurize milk, for instance, you can actually not refrigerate it. That level of pasteurization, you do not have to refrigerate it. Okay. The problem with that is most Americans, right, we're used to milk being refrigerated, so we get freaked out by the whole not being refrigerated part, right? The other thing is that much higher heat changes the proteins in the milk. So therefore changes the flavor profile of the milk, right? So most people in the United States do not like ultra pasteurized milk, right? And that's why some people too, they're like, well, you know, I drink organic milk, but I don't like the taste of it. Well, the reason why most people don't like the taste of organic milk and why is it different from regular milk is because organic milk, right, there are not that many dairy farms maybe in your area that produce organic milk. So in order for your store to provide it to you and it not spoil by the time it gets to the store or 2 days after you get it home, they have to ultra pasteurize it. So you'll notice, and again, they'll stick it in the refrigerator, and that's just to make you feel better and get you to buy it. It does not need to be refrigerated until you open it, right? But that's why it tastes different. So notice this particular organic company, I stole these pictures from the internet this morning to help you guys out. It's not my original PowerPoint. Notice this says local, right? So it very quickly goes to market so they can just do the standard level of pasteurization, which once it's been pasteurized, it's good for about 2 weeks. So it depends on, you know, when it gets to your store, right? And that's why it has that date on there, right? So that you know that about a week after that date, and it's going to vary, you know, and it just depends. And that's why, you know, they have to be transported in refrigerated trucks and stuff like that. And, you know, some parts of the world that's not as easily done. Now, some people grew up drinking, you know, like I've had students that have come from Europe, right? And they don't like American milk because they're used to ultra-pasteurized milk. right? And they're trying to find it. You know, they're like, where do you find it? And at one time, you know, there was a brand, a European brand, starts with a P, that was introduced in the United States. And it didn't do well in the beginning, too, again, because I just put it on the shelves and nobody was going to buy milk from the shelf, right? Instead of the refrigerator case, like, so they like even put it in the refrigerator case to try and get people to buy it. And like I said, the same thing, like anything that's ultra pasteurized, they just stick it in the refrigerator so that you will buy it, right? Not that it needs to be in the refrigerator, right? Because that higher level of pasteurization removes more microorganisms, so it has a longer shelf life. Make sense? All right. So now you know why.
Is there any kind of downside to doing that?
There are, I have to say that I haven't done extensive research into it. There are some that are like, you know, ultra pasteurization does more than just change those proteins to a taste that we don't like, that it may affect the minerals that are present and stuff like that. I don't know that there's truly been enough studies yet to know for sure whether it really is significantly changing the milk. And there are some people out there, oh, you should just drink raw milk. You know, I'm not on that bandwagon. I'll wait for the evidence to come out. I don't even drink milk, so I don't like it. Either one of them. When I was a kid, you didn't argue what your parents gave you, right? So the glass of milk went down on the table, and I chugged the whole thing right away. When it was nice and cold, right? Didn't get warm. I would just, yeah, again, you know, I would just chug the whole thing. So literally for years, like as an adult, I go visit my mom, and she's like, "You want a glass of milk?" I said, "No, I'll pass." And she's like, "Oh, okay." And my sister, and she's like, "Well, it's not from the farm anymore," because we literally had a local dairy farm we used to go and buy the milk from in glass bottles when I was a kid growing up. And my sister was like, "You don't know?" And my mom was like, "What? Erica doesn't like milk." "What do you mean Erica doesn't like milk? She's always drank milk." I'm like, "No, I chugged milk." Because my parents put in front of me, and you didn't argue when we were kids, right? You just drank it. But when I became old enough to choose, I chose not to drink it. I take my calcium pills. I'm good. You know, I get it from eating things like broccoli and other things. You don't have to drink milk, right? So it's a personal choice. I don't like it. So pressurized steam in an autoclave, right? And so this is what, you know, most places use to sterilize equipment, what we use in the microbiology lab to sterilize things. And again, it's going to depend on, you know, what your level of organism. Are we killing organisms? Are we doing our media that should mostly not really have any contamination? And the benefit to the steam under pressure is we can get much higher temperatures. Now, you wouldn't want to pasteurize your milk, right? Because this level, right, it would become a big glob, right? Those proteins would become so coagulated, right, that it would basically be cottage cheese, right? Yeah, it would be gross. And so that's the main reason why we don't sterilize some things. It changes it to that extent that we wouldn't want to actually eat it. And that's why some heat-sensitive things, we can't sterilize it, right, by heating it to this extreme level. So although I hate to do this to you guys, test is still Monday, right? I'll post, like I did for growth, a recording of this lecture. So probably one of the most important points that I am going to go over with you is this fact of heat sensitive, right? So there was probably to relate to your own lives, there was a time when you didn't stick plastics in the dishwasher. Why? It would melt, right? But they have different plastics now that are much more heat resistant that you can put in the dishwasher. And so again, it falls back on this, that some things you just cannot heat. You're going to change it in such a way that it's no longer usable, right? Like the plastics. So that gives you a nice good visualization, right? And why we use some of these other methods, right? Like filters and irradiation. And guys, we're talking about the type of irradiation that's not radioactive, right? Don't freak out that some of your foods now and your medications and things like that, right, is a different type of radiation, right? And as we already learned before about UV light, right, that's damaging DNA, but it's not very far penetrating, right? So we can't use it to, like, do your hamburger, right? It won't penetrate far enough. And then a new advent is pressure, right, is putting things under pressure. So there are different type of filters. Make sure you read over that, and for those of you guys that want to hear it, as I said, I'll post that other lecture for you. Microwaves. They heat up liquids, right? And so much so that a lot of the times they evaporate. That's why a lot of times your foods that you stick in the microwave dry out, right? So I was taught a long time ago when I was still eating rice, take a wet paper towel, put it over the top of the bowl, right? And that'll help maintain the moisture, right? So you got to add moisture, right? Because that's what it's doing, is it's heating up the liquids, right? And that's how, too, it'll help prevent, is that the liquids get heated up, right? Those molecules start bouncing around like crazy. And that's how microwaves work, right? They're vibrating those liquid molecules, right? Which generates heat in whatever it is you're nuking, right? So the same holds true, like, you know, we heat up stuff, and you could disinfect that way, right? So nowadays, too, like, they have those containers that you stick the baby bottles in, and you add what to it? Water. And it's that liquid that heats up that generates the steam, right, that helps sanitize those bottles and the things for the babies, right? Instead of running the dishwasher on sanitize, right? Same method, same similarity. So humor me, guys, for about 5 minutes. Just want to make sure. Okay. Any important ones that I wanted to mention, I did.